Distance and displacement. The length what you traveled may differ from the position where you are. For example, you consider in this map, this is your house, this is bookstall, and this is your school. The distance between your home and bookstall is 60 meter. Bookstall and school is 80 meter. And the distance between your house and school directly is 100 meter. Suppose you want to go to school through the bookstall, then how much length you have to travel? The 60 plus 80. But actually at a distance of 100 meters from your house. Now the length of the path what you have traveled, that is called distance. And the shortest distance between initial and final position is called displacement. A distance, it is the length of the actual path described by a particle in motion, and displacement it is shortest distance between initial and final positions of a body. For example, you consider 2 points A and B. A particle travels from A to B along this path. The total length of this path is called distance, and the shortest distance between these 2 points is called displacement. The units for distance and displacement are same. In CGS system, we use centimeter. In MKS and SI systems, the unit for distance and displacement is meter. Now again you consider this example. In this map, you are observing that the distance between your house and bookstall is 60 meter. Bookstall and school is 80 meter. The distance between bookstall and health center is 40 meter. And the distance between your house and park is 40 meter. The distance between park and bus stop is 50 meter. Bus stop and school is 120 meter. If you want to go to school, you can go by any path. If you change your path, the distance varies or changes. In this figure, if you select this path, that is house to park, park to bus stop, then to school, then how much distance you have to travel? 40 plus 50 plus 120. It is 210 meters. But the displacement is 100 meter only. Suppose you go to school along this path. That means from your house to bookstall, bookstall to health center, then health center to school, as you are seeing in the figure. Then the total distance you have to walk is 60 plus 40 plus 80 plus 40, which is equal to 220 meter. But the displacement is 100 meters. Similarly, if you go by this path, how much distance you have to walk? 60 plus 80, that is 140 meter. But the displacement is 100 meters. In this case, what you are observing? The distance may change, but the displacement is constant. The magnitude of the distance that depends on the path what you travel. But the displacement is the shortest distance between initial and final position. It is always constant and it is along this direction always. That means distance has only magnitude but not direction. But displacement has both magnitude and direction. Therefore, we can consider distance is a scalar quantity and displacement is a vector quantity. Already we know that scalar is a physical quantity which has only magnitude but not direction. Examples of scalar are mass, distance, time, speed, density, temperature, etc. And vector is a physical quantity which has both magnitude and direction. The examples of vector quantities are displacement, force, velocity, acceleration, etc. Distance is a scalar quantity since it has only magnitude but not direction. And displacement is a vector quantity. Always the displacement is along this direction.